basically what the bad guys do is they first they do the research on us, and then they come into your network, and then they do the discovery process, where a lot of times they'll develop even better diagrams and asset inventories than we have, and then the next step for them is to actually aggregate all the data. They obtain the data, and then they exfiltrate the data. So along all of these steps, we have the potential to detect and stop the adversary. So one of the first things we need to do in detecting the adversary is to understand the adversary. So one thing is to understand what their motives are. So one type of threat is the hacktivist, the anonymous guys, the guys that are in this not really to make money, but to make a point. So we have those guys are one threat. Another threat is the cyber criminal, and these guys we're seeing a whole lot more of these days. Actually, you may have seen that this morning there was a drive-in attack in the UK where they stole $50 million from a UK bank, and so this is an active. The cyber criminals are very smart. They're very motivated, and they're very active, especially in the healthcare space. Or earlier we heard about the OPM breach, but I'm getting ahead of myself. The OPM breach is the next one. The generally accepted that the OPM breach was done by the nation states, and so from the nation state perspective, they are actually also leveraging the cyber criminals to expand their knowledge and what they can do. The cyber criminals are actually a very interesting lot, because they progressed a lot over the last couple of years. Maybe they're in my network right now. They didn't like that comment. So basically what they've been doing is they have done a lot of divide and conquer. So they have the segregation of duties. They basically say, oh, I'm good at this process, so I'll focus on that. Somebody else is good at, So they basically got the people to go out and steal the data. They've got the people to write the malware. They've got lots of different processes that have been segregated within the environments, and they it's available online on the dark web. So they have essentially their own communities where they can buy credit card information. They can buy malware. So that they're very sophisticated, and we really need to become as sophisticated as they are. So how do we do that? How do we get to be as sophisticated as they are? So we basically have to emulate them. They've been emulating us, and now we need to turn the tables and emulate them. So basically we need to do a lot more collaboration. So we need to understand how they're working, and one way to do that is for us to work together. So basically we can understand the evolving threats as it's happening. And so a lot of companies are now offering threat intel services. There's commercially available, there's open source, and then there's also the ones that are put out by essentially the government, the ISACs. The government came up with 16 critical infrastructure areas, and they have ISACs information sharing forums. And so let's see a showing of hands of who's actually involved in ISACs. And which ISACs are you guys in? So it looks like we only have FS, financial services, and healthcare represented here today. So another 14 of them y'all have to get involved in, assuming that there's more than healthcare and financial services people in the audience. And actually they, one of the big advantages to those is that they actually have platforms in which the information can be shared in real time, so that if, just like the attack that happened in London last night, the rest of the community could get the lowdown on the what was really happening in that environment, what the attacks were, and how to protect against those attacks. And so active involvement from the threat perspective is very important. So while I take a drink, do we have any questions about threat sharing? Sure.
A lot of the threat intelligence that we see right now seems to be at a point in time.
I'm
like in the past.
sorry.
The threat data that we tend to see seems to be at a point in time. It seems to be in the past. This has happened in another. This is not actually a address of a known attack in another organisation that we're aware of. How do we stay one step ahead of attackers on
So the question was, it appears that the threat intel that we have is only is from the past. You know, how can we get so that we're one step ahead? And actually, I'll just take a little sidetrack on the IP address perspective. The big challenge with the IP addresses is that the malware has gotten sophisticated enough that they're not using standard IP addresses, so that they're not static. They're constantly changing their IP addresses. So that's a huge challenge. But there are tools out there that and I'll get into how we can address that particular problem. But the whole point of the ISACs and the whole threat intel is to be able to get the real-time information so that you can very quickly respond. And so it's they also have developed the sticks and taxi. So I think I'm getting ahead of myself again. So let me look at my next slide. Here we are, the sticks and taxi. So basically what's now available is the ability to take threat intel information and actually make it actionable. So basically we have over here all of these various organizations that are collecting information, and then it's being normalized. And the reason you have to normalize it is because if you've got one virus vendor finding a problem and another virus vendor finds a similar problem, they call it two different things, and then you think you have two different threats, but in fact so thus you have to normalize it, and then it needs to be analyzed in depth and turned into some actionable intel. And so the beauty of the sticks and taxi is that it actually gives you the capability to integrate the intel directly into your environment. So a lot of organizations are a little reluctant to actually turn it into literally actionable intel at the moment, but I would anticipate that in the future that it will become real-time actionable, so that when the indicator of the compromise comes in, then sticks and taxi will then put it not only in the SIM for detection of that type of attack, but also it will put it in the IDS and the IPS, so that your intrusion prevention system can actually actively prevent that attack from happening. Yeah, question?
I have a question on strategy from a management perspective. When we have someone selling IOCs, right, versus coming in with a sticks and taxi, right? Do you see a lot of firms taking a strategy of not purchasing the IOCs from the various vendors and relying more on the sticks and taxi fees, which eventually should incorporate those by the nature of
No, he had a comment. So the question, or the comment was that if you want to ask a question, please use a mic so that the people later are able to hear the questions.
I should have used the mic.
Good point. Okay, so now we'll move on to essentially the first level of defense. So the perimeter defense. So some, much like the Microsoft guy this morning was saying, some people say we shouldn't bother with antivirus because it only catches 60% of the attacks. But some people are saying something similar around the perimeter defense as well. I think that it's a bad idea to just throw out both, that you really need to have both of them in place in order to be able to prevent attacks from happening. So in the conventional perimeter, we have protection against five or six different protocols, and they're able to stop a fair number of attacks. Recently, there's now the advanced threat protection, which gives you the capabilities to do much more at the perimeter rather than just the firewall, but rather to have the next gen firewall. So it will actually identify the malicious content and also detect the infected hosts. And so what are we looking for? We're looking for malicious content as well as suspicious communications, and I guess to me that's all pretty self-explanatory. I don't want to bore you. And then also attack behavior. And so how is that done? So it's done by looking not only at the basic levels of protocols, but also expanding beyond the 4 or 5 protocols that are traditionally included in a firewall. And so on my left side, your right side, we have listed out all the protocols that are actually in Poison Ivy. And so you can see that there's a need for a sophisticated perimeter protection, given that there are so many different ports being used. And then the next one is to include some level of sandboxing, because sometimes it's not apparent at all in looking at the network traffic that in fact that it's malicious. And so it's important to have in your environment a sandbox technology that allows you to see what would really happen. And in the good sandboxing technologies, there's the ability to actually have that sandbox look exactly like your environment, because it's not really going to do much good if you have a standard Microsoft Windows 2003 server in your sandbox, and they have and you don't have Windows 2003. So it really needs to be customized to your environment. Now, cyber analytics. So cyber analytics is really critical to detecting the bad guy in your environment. And there's different levels of analytics, and so this is very much a work in progress. The end game is to be able to have the machine learning and to have the sentiment analysis and understand motivation and really be able to do it through visualization. But that's the long term. For the near term, we really do have the capability to do a lot of user behavior analytics, to do network analytics, DNS malware, and so this is the trend. These are the trends, and I'll share these slides with you. So anybody that wants, I believe the conference is actually going to make them available to you as well. So let's get into a little bit around the user behavior. Oh, I guess we're doing DNS analytics first. So DNS analytics is actually a very interesting space because at first, you might think, well, DNS, what good is that going to do? Well, for one, you can detect the fact that your DNS has been poisoned, but also it gives you the capability to detect endpoints in your environment that have been compromised. Because basically, much like was talked about earlier, you've got the IP addresses, the reputation-based ones. So that's one option, but that could be done through other means. What the DNS analytics will really give you is the ability to detect those very sophisticated attacks. So what command and control centers are doing these days is they set up the malware such that the malware will, when it's spun up, it will talk to, at a specific time, in an AWS environment, a command and control center that's also spun up for just seconds. So basically, both turn on, they ship the data out, and then they turn off. And so you, in a reputation feed type of process, you're not going to be able to detect that. And especially in an AWS environment, those virtual machines and those IP addresses are being reused. So if you put that in your reputation database, then you may in fact be denying access to legitimate systems down the road. So I guess any questions on DNS analytics? Okay. So then let's talk a little bit about user behavior analytics. So this is actually one of the very good ways of detecting malicious actors in your network. So basically, the user, you need to look at the user from multiple perspectives, from the applications that they're accessing, from the identity attributes that they have. Are they super users? Are they, from the human resources perspective, are they good employees? Are they, does HR have them on a PIP program? Do they potentially have malicious intent? So then what you can do with the user behavior analytics is to actually baseline their activity. So get to understand what's the normal activity for that user, and then you can understand when they start to do things like download huge amounts of files from the network or from your network, do big attachments to Gmail, assuming that you even allow them to do that kind of thing. But then, so you can actually detect malicious activities from what they're doing, and this is actually what's the kind of the leading edge at the moment from the threat detection is to actually do the profiling of users. Some of these tools are sophisticated enough that they're to the point that you can predict when your employees are going to be exiting. So you can figure out that, this guy is going to LinkedIn and looking at jobs, or Indeed, or wherever they're going for jobs. And so you can get into some privacy issues with some of these tools. And actually, we've seen that especially in Europe, that some of these user behavior analytics tools are considered to be invasions of privacy. Yes.
So
what about the mic?
So user behavior analytics. Okay, a lot of us here work on, say, red team side. So wouldn't that automatically trigger off an insider threat? Because we're always nosing around, we want to know everything about the company. We always work late, and HR always deems us as bad. So what's the false positive ratio?
Well, actually, if you're always doing that, then that would be the normal behavior for members of a red team. Because one of the other advantages of user behavior analytics is you can actually set up groups so that when you, like his red team example, or system administrators are another typical example, where you have the user themselves, their behavior, and then you have the other people that are in their group and what they're doing. So if you've got system administrators and they're all just accessing a bunch of servers, and then you've got your 10th system administrator, and he's going off to finance, he's going off to HR, he's perusing the network. That's a suspicious behavior. And so in his red team example, if these guys are always doing application, let's say they're application-based red team, and then they start to do attacks against systems or accessing cloud applications, when that's not the norm for their type of role, then you can detect that and have a lower false positive rate. Oh, can we have the mic? No, I think I actually have the mic.
Cindy, I was just wondering, you mentioned this is a sort of, it's an evolving control. How scalable is it? I can understand it maybe working for small organizations with hundreds or thousands, but what about like if you've got like 10,000 employees or 100,000 employees? How practical a solution is this?
So it has been deployed on hundreds of thousands of users. So yes, it's practical. It's a matter of establishing the baseline across all of the users in the system, but it's feasible to do it. So I think so. What time is it? I don't have the time up here. I'm sorry? 12:06. Okay, great, thanks. So I guess any other quick questions on the user behavior analytics before we get into the application? Detecting, no? Okay, great. So now we'll look at detecting the bad guy through your applications. So we heard earlier, about the whole SDLC lifecycle process and processes for detecting vulnerabilities in your code. Well, there's the potential that even if you are able to detect the vulnerabilities in your code, that the zero-day attacks may be happening, or you may have applications that are on legacy applications, and that maybe you're not willing to spend the money to fix them. So there's RASP, runtime application self-protection, which gives you the capability to actually put a control in place around the applications themselves. So that basically, as the application is running, the RASP sits on the application server and detects vulnerabilities as they're happening. So basically, it's a great way for putting a control in place when the security organization doesn't have a lot of control. What we have seen in some of our customers is that what they're doing is they're saying that if you have an exception, that you have to put this process in place for any applications that have vulnerabilities and they have a need to have an exception. So it provides a greater control from the application perspective. so the logical question for you would be to ask, why would I want that? I've got my WAF, and my WAF will do, will protect me from the application perspective, the web application firewall. So there's a huge difference between a web application firewall and a runtime and a RAS. So basically, the RAS, it gives you the ability to analyze the applications at the runtime, and so there, it doesn't really matter what protocol you're using, it will be able to manage the protocols from HTTP or HTTPS. Actually, speaking of HTTPS, one of the big advantages is that since it is running on the application, it actually understands the decrypted information. So like with a WAF, the information is still encrypted. So if you're using encryption on your applications, then its WAF is not going to be able to see the data decrypted. Whereas with a RAS, the data will actually be decrypted because it's actually in between the application and the actual running of the application. And it's also much more accurate, and it tends to be highly efficient as well. It's also scalable, since basically you can put it on any of your application servers, and it tends to be reliable and extensible as well. So do you understand the basic concept of what RASP is? Any questions on RASP? So basically, I'm taking that, but you didn't really quite grasp what a RASP was. So RASP really reside on the application itself. So let's use SQL injection as an example, right? So you've got well, actually probably cross-site scripting would be better. So you have an attack happening against your application, and what RASP will do is actually see that as it happens from the application perspective. So it understands what the normal behavior in your application is, and it will detect the fact that you've got some malicious code in being executed. So if you don't have the validation of what are they called? So when you have a field and it's not having proper validation, and you can actually execute code in that field, this would actually detect that the code is being executed and it's not supposed to be being executed. So I don't know, I'm still seeing quizzical faces. So maybe if you ask me a question, I can get more down to the nitty-gritty of a RASP. Yeah, so RASP really, from an application perspective, they give you the capability to actually monitor the application as it's running in real time. And so it's an excellent tool to be able to get a much tighter control in the application space. And as I said earlier, it's actually a control that's being used by the financial firms to actually make sure that they have a tighter control when an exception is required. When they have an application that doesn't meet their security standards, they put the RASP on the application servers so that they can actively monitor what's happening within the application. Okay. So then next up we have the data security information self-protection. So basically, I think what we've heard today is that you know, there's a lot of porousness to our perimeter, so that the bad guys are getting in, and what they want is data. So if you look at the OPM breach, they wanted data, the target breach, the JPMC, what have they done? They extracted huge amounts of data. So from the data self-protection concept is that we should be doing protection of the data since it's inevitable that they're going to get in. So let's just start encrypting the data, protecting the data itself. And that's far more complicated than you might think, because you have a ton of different options on where you can encrypt the data. So you can encrypt the data at the file system or storage level. You can encrypt at the database. You can encrypt at the application level. You can encrypt at the file level, and then you have multiple types of data. You have structured data. You have unstructured data. Oh man, there's so many things to do. What am I going to do? So if you have a checkbox, and that's all you're really interested in, then you encrypt at the storage and the file system level. Or at least that's what we're seeing our customers doing. Is when they have a checkbox that says, "Oh, my data has to be secure. My data has to be." It's basically a compliance issue. Then they do the first two. Then what we're also seeing is that a lot of organizations are getting much more sophisticated, and they actually want to just encrypt the data that's sensitive. You know, so that and there's a couple of reasons why you would want to just encrypt the data that's sensitive. One is that there is a fair, especially from the database perspective, if you encrypt your whole database, that's a huge amount of overhead. And also, if as we were talking about earlier, that the bad guys get into your environment and they are able to take over the identities of people in your environment, then all you have to do is get in and they can access all of that data. So if you take, it's much more interesting when you get into the file level and the data encryption itself. So now what's available is field level encryption, which gives you the capability to encrypt data in a particular field. So typically what we're seeing is people are doing encryption at the credit card level or social security numbers. So then even if somebody comes in and is able to suck all the data out of their environment, they're not going to be able to do anything with it. And this tool actually gives you the capability to do encryption at different partial encryption of fields. So for example, like here, this one. So the social security number, sometimes the last 4 digits are used by your help desk to verify the identities. And so that can be decrypted specific to some users with your web interface. The really big advantage of this is that when you're looking to implement it, you don't have to redo the backend database. Because if you're in application development, you'll fully understand the implication of general encryption. What happens is you take a 10-digit number, you encrypt it, it comes up with more than 10 digits. And so that means you have to redesign the whole backend database. And that makes this a much more difficult problem. When you're just doing the field level encryption that's format preserving, you have the capability to do it at a much more cost-effective perspective, and you still get the value of doing the encryption. So, just an FYI, HP has a tool that does this. A shock of all shocks, right? So next, we also, I'll just build this thing out. Need to think about not only our own environment. We also have to consider how things have changed, and what's happening within the technology. So you have all of those cloud applications, you've got your SaaS, your IaaS, your PaaS, you've got your applications like the shared Salesforce, that ranking, all of these applications that your customers or your staff are going out to, and then also from the perspective of the ability to actually have a credit card and purchase any type of cloud service that you like. That's also a major consideration. So the way that you can protect this type of environment and detect the bad guys in this environment is to actually have what's called a cloud security access broker. And so what that gives you is the capability to understand what your users should be able to access, what they are accessing, and what they should not be accessing. So in this example, we have your user being subject to a phishing email, and in this example, they fall for it. They click on the link. The bad guys infiltrate their network. They install a backdoor, and the hacker is attempting to take action. And that's all happening, within less than an hour. And so, what the cloud security access broker is able to do is to detect this activity and actually prevent it from happening. So basically, the access broker will actually build heuristics around this type of attack vector, and you'll be able to detect when malicious activity is happening, not only within your network, but when with cloud-based services that your environment is taking advantage of. So, are any of you actually actively using cloud access security brokers? You're planning to? Actually, there's a lot of, I guess I would highly recommend that you actually start actively looking into these, because almost all organizations, whether they know it or not, are moving to the cloud. And one of the great features of a tool like this is that it will actually tell you that your users in your environment are actually actively using the cloud, even when you think that they're not. Because I guess I talk to a lot of CISOs that say, "Oh, we don't use the cloud," and the person sitting right next to them at the table will say, "Oh yeah, you do. My service is in the cloud, and you guys are our customer." Okay, so it's definitely an area that you should consider doing some analysis on. Actually, the other area that cloud security access brokers give you the capability to have some control around is actually the safe harbor. I don't know if you're familiar that there was a major change in the safe harbor ruling that basically the UK, or not the UK, the EU said, forget safe harbor, and they didn't give any timeline for when you could you had to be compliant. So basically they said, we don't want my version of this is Europe said, we want our data in Europe, and you can't take it to the U.S. And they, because they want to make sure that our infrastructure is providing the same privacy as the European infrastructure. And based on Snowden, the documents, they say, hey, you're not meeting our security and privacy requirements. And gives you is the capability to understand where your data is and where it's going. So one thing that a cloud access security broker can do, if you have European units, business units, you can set this up in place, and it will actually monitor the data as it's moving from one environment to the other. And it will give you the capability to actually not allow this in conjunction with IDC or RDM, digital rights management, will give you the capability to control your data such that as the data is moving, attempting to be moved from Europe to the US, it would take away the rights to be able to see that data. And so it's actually a very, very strong use case for data protection in light of safe harbor. And actually, we have some customers in Europe that basically are doing that. They have implemented security such that if a document or data is leaving one country to the next, that all access to that data is taken away. So basically, from the cloud security perspective, we have the discovery, the control of the data, the access activities to the data, and then also the detection of the threat. And so that's the capabilities of cloud security. Next, we have to consider mobility. So you have data in applications and devices and storage, and so the whole control of your data is very important. And the big challenge from the data perspective is it's multiplying the amount of data is really running away. And I realize I'm running over on time, so we will zip to the end. So in summary, we have detecting the bad guy in your network. So there's, I think, a couple of important steps that we've gone over today. So one is to actually be aware of the threat intel, the cybersecurity threat intel, and to be able to make that actionable. Next is to make sure you've got some level of perimeter security and is using the latest technology, which includes the advanced threat detection, and that would also include sandboxing and behavior analytics, both at the network behavior as well as the user behavior analytics, the application security, the runtime application self-protection capabilities, and the cloud security access broker, along with like a digital rights management IPC solution and protection at the data level itself. And then all of these tools actually would feed information directly into a single pane of glass that would really be able to give you actionable intelligence that you can take action on. So any comments, questions? Somebody should have a question. I wasn't so crystal clear that you don't have a question. So how about who thinks they don't have any cloud, that are not using cloud at all? You're all, oh, that's good. That's good. Everybody admits that their environments are in the cloud. So what tools are you using to detect rogue cloud users? Oh, everybody's taking the fifth on the rogue cloud users. So I guess you all must be hungry. You just want to run out the door to eat lunch. Okay, well, thank you very much. I appreciate you attending.
Cynthia, thank you very much for a great presentation. On behalf of Program Committee and Steering Committee, I'd like to present you with Speaker Award.
Oh, thank